So how do we actually find then the gradient function for any curve? I mean, lines and semicircles, terrific, but there are a lot of other shapes. So in other words, how do we find the slope of the tangent to the curve? So here's just some random curve, y equals function x. Let's say the point we want to investigate is P, and there's my tangent, which I've called the line K. We saw that we could estimate it with a secant. This time I've got the secant going through P and another point on the curve Q. So PQ, the slope of that, would be an estimate for the slope of K. Admittedly not a great estimate, but it is an estimate. So where should I place Q to get the best possible estimate? Well, as we slide Q closer and closer to P, then our estimate is going to get better and better. So ideally I'd like to place Q as close to P as possible. In fact, if they were the same point, then it would be perfect. All right, let's have a look. P is going to have coordinates x, function x. Q, I've just added a bit to it, so I'll call it x plus h for the x value, and the y value will be function x plus h. So the slope of that would be, using our normal slope formula, function x plus h minus function x over x plus h minus x, which tidies up to be h in the denominator. But as I say, to get that exact value, I want Q to be the point P. Well, obviously it can't be the same point, but let's investigate using this idea of limits. So as the distance between the two, as h is approaching 0, what is happening? So my slope of a tangent will be the limit as h approaches 0 of that expression we just found. Function x plus h minus function x over h. This is what we call the derivative of y with respect to x. And it's basically saying, how is the y value changing as x changes? Symbols we use for the derivative. dy dx is a very common one. The letter d, I guess, comes from the Greek letter delta, and delta is often a letter we use to signify change. A y dash, or an apostrophe, f dash x, and sometimes we just say d dx, and then we say the function that we're referring to. So our derivative is a measure of the rate of change. So how is something changing? Instead of saying the slope of the tangent, I'll just put the notation for the derivative there, and I've used the f dash x notation, mainly so it matches up with the right hand side where I've also used function notation. Now when we use this formula, it's called differentiating from first principles, the first idea that we looked at. So okay, let's do one where we know what the answer should be, because this one's a straight line. Remember, we said the derivative or the gradient function for a straight line would be the coefficient of x. So we should end up with 6. So function x is 6x plus 1. Function x plus h would end up being 6x plus 6h plus 1. And so my derivative, h approaches 0, let's sub in. We've got some tidying here that can do. The top of the fraction, the 6x's will cancel, the 1's will cancel. 6h on h, the h's will cancel, and we get a constant 6. So as h approaches 0, we're going to approach 6, because it's 6 everywhere. And that confirms what we knew was going to be the answer. Well, let's apply it to this one, a parabola. So y equals x squared minus 5x plus 2. We want to find the equation of the tangent. Well, in order to do that, we need a point and a slope. We've been given the point. Now we want to find the slope. Slope of the tangent is the derivative. So function x plus h. Let's expand all that out. Okay, let's sub it into our formula. Now this time I've used the dy dx notation. Okay, again we've got a bit of cancelling there. We end up with 2xh plus h squared minus 5h. Can't sub in here or I'll get 0 on 0. H will go into everything, so let's cancel that out. 2x plus h minus 5. Sub in h equals 0 and we get 2x minus 5. Now 2x minus 5, remember, is not the slope of the tangent. That is the gradient function. So it's the function that will allow us to find the gradient. We want to know when x equals 1. So at x equals 1, I can substitute into our gradient function, and we get a slope of minus 3. Okay, so we know the slope. We want to find the equation of the tangent, point slope formula. So y minus y1 is m outside of x minus x1. Playing around with that, I've left it in y equals mx plus b form, but there it is, y equals minus 3x plus 1. All right, so let's have a go at 9b.